Hello everyone and welcome to Grinds Online Ireland. I'm Tara and today we're going to be covering some algebra, specifically some tricky questions. So our question today is alpha. So that's a Greek letter there, guys, and how we say it. It's called alpha. Alpha and 1 over alpha are the roots of a quadratic equation 3k x squared minus 18t multiplied by x plus 2k plus 3 is equal to 0, where t and k in the equation are constants and we don't know what they are. And it's our job to find the value of k. So guys, the trick with this question is realizing for roots, when we plug it into the equation, we'll get 0. So we'll get 0 on one side and 0 for the other. So the equation is true. So if I plug in the first one, alpha, into the equation, everywhere I see an x, we're going to get 3k alpha squared, because there's an x squared, minus 18t, and then we're going to get alpha, plus 2k plus 3. And we know that's going to be equal to 0. Similarly, I can do the exact same with the 1 over alpha. So everywhere I see an x squared, I'm going to put in a 1 over alpha. So we have 1 over alpha x squared minus 18t, and then we'll have a 1 over alpha instead of the x, plus 2k plus 3. And we know now that will also be equal to 0. And another way of writing 1 over alpha, all that's squared, you should remember that from your indices rules, is just 1 over alpha squared. So we can rewrite this as 3k 1 over alpha squared minus 18t 1 over alpha plus 2k plus 3 is equal to 0. Now guys, we have a lot of fractions here, don't we? So how about if we get rid of the fractions? And the way we can get rid of the fractions here is multiplying by the highest power of alpha in the bottom on all the denominators. And in this case, the highest power is alpha squared. So if we multiply everything by alpha squared, what we're going to get is this alpha and this alpha will get 3k alpha squared multiplied by 1 over alpha squared minus 18t alpha squared 1 over alpha, and then plus alpha squared 2k plus 3, and all that is equal to 0 multiplied by alpha squared. And we remember, because we're multiplying both sides by alpha squared, so this left hand side or right hand side will also have to be multiplied by alpha squared. Now if we look here, we can see that the alpha squared here cancels out this alpha squared. One of the alphas up here cancels out this alpha. So we're just going to be left with 3k minus 18t alpha plus alpha squared 2k plus 3. And we know that's equal to 0. So we have one equation where we plugged everything in and it was equal to 0. And we had another equation, and when we plugged everything in, that was equal to 0. So if they're both equal to 0, then they must be equal to each other. So we can say 3k alpha squared minus 18t alpha plus 2k plus 3. That's the formula I got when I substituted in alpha squared. That must be equal to 3k minus 18t alpha plus alpha squared 2k plus 3. So guys, when we have two quadratics, one quadratic on the left hand side and one quadratic on the right hand side, an algebra rule is, just like we come up with this in complex numbers a lot, the coefficients in front of the alpha squareds must be equal. So the numbers in front of them, the coefficients in front of the alphas must be equal. And then as well as that, the normal numbers must be equal. Okay, or not. So if we could look at any one of them, but let's just have a look at the numbers in front of the alpha squareds. So the number in front of this one, the left hand side, 3k, that must be equal to the number in front of the alpha squared on the right-hand side, 2k plus 3. Now that's just one equation with one unknown, so we can solve that no problem. So if we bring over the 2k, it becomes a minus 2k. So we're just left with 3k minus 2k, which is k. And on the right-hand side, we're just left with 3. So our final answer then is k is equal to 3. And we could have done the exact same thing with the normal numbers or the numbers in front of the alpha, and we would still get k is equal to 3. So the most important thing, guys, to remember out of this question is that when you have roots of a quadratic equation, when you substitute those into the formula, just like we substituted alpha and 1 over alpha for x squared, we should get the left-hand side and the right-hand side are both equal to 0.